Okay, it's time to start. I'll send it later, no problem. I'll send them in the break or something. Okay, let me see if anybody is struggling in the group who has sent a message. Maybe he's not seeing a message or something. Is there anything in the group? No, nothing. Okay, guys, I'll share the screen and we'll get going with the content, that is SFBM. Unless you have any doubts, please let me know from either moment of inertia or from Bilging or from any past paper, which may also involve any prior learning. So if you have any doubts, let me know. Else we get going with SFBM. Okay, guys, I'll share the screen also with you. Just give me a second. We use tomorrow, so I Okay, guys, kindly confirm if the audio visual is clear, then I can start my explanation. Is it clear, guys? Audio visual both are clear? Okay,
Yes,
Yes,
sir.
sir.
clear. So we are good to start. Now, guys, when we do SFDM, the first thing we need to understand that our questions are based on two things. One, a beam, and beam also limited types of beams. And then it is also based on what we call as the box-shaped vessels. Okay. Now we'll start with the beam and then gradually graduate to box-shaped vessels. So like the previous topics, each day of the learning would be connected to the next day and you'll be carrying forward the learnings to the next day. Please let me know at any stage when you feel that you've not understood anything. It's a very simple, straightforward topic. It has not much of relevance with prior learning, not much, little bit, of course, law of flotation and all that can keep coming, but not much of relevance. So if you start it afresh with very basic prior learning concepts, which will be used here and there once in a while, you should be able to pick up this topic. Now, guys, when we talk of beams, there are certain terms that we'll be using in our questions, in our discussion. And every time the term is used, it will have a definite meaning. So we'll not keep changing the meaning of the terms every time. So we'll just try to understand what type of beams are going to be in our questions and how are we going to draw the diagram. Guys, we saw in moment of inertia, diagram held the key. We saw in bilging, diagram held the key. And so would the diagram hold the key in SFBM also. Okay. One type of beam that will be coming in our discussion is a light beam. What is a light beam? Light beam is a beam which basically whose own weight is insignificant or negligible or inconsequential in context of the question. That means the beam weight will not be in consideration in those questions. That is what is meant by the light beam. Whenever I have to draw a light beam, I'll also always be drawing by a single straight line. So whenever in my diagrams, we have to represent a light beam, we'll use single straight line. Is that clear, class? What is a light beam? Is that clear? Clear, beta?
Yes, sir.
Yes, sir. Yes.
The second type of beam we'll be using would be a beam of uniform cross section. When you say beam of uniform cross section, the beam would have a weight. Then what is the meaning? What is the significance of these words here? Uniform cross section. That means if you cut the beam at any point along its length, its cross sectional area at every point will be same. I'm not talking about the shape of the cross section. I'm talking about the area and shape. So if it is circular at one point, it will be same circle at the other point. If it is square at one point, it will be square at another point. If it is triangle at one point, it will be triangular at another point. If it is irregular at one point and the same irregular shape is at another point, there will be beams of uniform cross section. So what is the significance of this word uniform cross section? This means that the weight of the beam is uniformly distributed over its entire length. Weight of the beam is uniformly distributed over its entire length. So suppose a beam has a weight of small w and length L. That means the weight of this beam per meter. So that means weight per unit length will be W upon L. How would we represent a beam of uniform cross section in our drawings? I shall be representing a beam of uniform cross section like this with a certain thickness and shading it. This diagram represents the beam of uniform cross section. This is how we'll represent, but this beam could be like this. This beam could be like this. This beam could have been like this. This beam could have been like this. They are all examples of beams of uniform cross section. So is the beam of uniform cross section clear? It is not necessarily rectangular or square. It can be any cross sectional shape. Am I clear, class? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
But whether it is A, it is B, or C, in our diagram will represent like this only. It doesn't matter what is the shape of the cross section. Okay, so we'll have beam, light beam, and beam of uniform cross section. In real life, you can have beams of different types also. They will not be part of our questions. For example, you can have a wedge type beam where the weight is cross sectional area is increasing gradually. So the weight is also increasing from one end to the other. Or you can have a non-uniform beam. This is a non-uniform beam. Or you can have this beam. They are all, because if I cut it here, it will be different. If I cut it here, it will be different. These are not part of our syllabus. They are there when you do engineering or something. But in our syllabus, we'll be dealing with light beam and beam of uniform cross section only. Is that clear, class? Because it should not send you a message that there are only two types of beams in the world. No, there can be different beams. But we will be dealing with only two types, either a light beam or a beam of uniform cross section. Any questions on types of beams and how would they be represented in the diagram, guys? Is that clear? Clear, beta?
Yes, sir.
Yes, sir.
Okay. Now these beams we'll be putting some, we'll load. Why do you have a beam? Because you want to put some weights on it. You want it to support some downward forces. So what are those weights, types of weights, or the forces which can be loaded or placed on the beam? Now these type of weights and forces again there could be a point force or point weight. What do we mean by a point weight or a point force? That means the given force that is there is is acting at a single point on the beam. Is acting at a single point on the beam. How would we represent force or a weight on the beam? If it's a light beam, we'll draw the beam like this. And suppose at A there is a point force. Let us say at C there is a point force. We'll put a downward arrow like this at these points to indicate that there are point forces at A and C. Suppose it is 20 Newton at A, I'll write here. If it's 30 Newton at C, I'll write here. And this is how the point forces will be representing in the diagram. If it was a beam of uniform cross section again, so first we'll draw the beam. And let us say we have these points A and C here and there. And they you have again point forces. Then you'll put 20 newtons here and 30 newtons here. Is it clear how what is meant by point force or a point weight, whether we use the word weight or force, and how they would be represented on a light beam and a beam of uniform cross section? Am I clear, Bita?
Yes, sir.
Yes, sir. Yes, sir.
The second type of weight that will be used in our discussion will be uniformly distributed load or weight, whatever you want to call it. And in questions also, its abbreviation is used sometimes, UDL. UDL stands for uniformly distributed load. What does it mean? That the given weight is not acting at a single point, it is distributed uniformly over a certain length. Let us say we have this light beam of AB of 10 meters length. Suppose from end A to 4 meters of length, say up to here, the beam carries a UDL of, let us say, 100 newtons. That means 100 newtons is placed on this beam from here to here, and this weight is again uniformly distributed. What does it mean? That means if this is 100 newtons over 4 meters, it is distributed at a rate of 100 divided by 4, 25 newtons per meter. Am I clear, beta? Yes or no? Clear, class?
Yes,
And suppose I have a beam of uniform cross section, again 10 meters in length, beam AB, and I want to load over left 4 meters with 100 newtons as in the light beam scenario. Then I will load it with UDL from A to 4 meters of length, and the UDL will be placed like this. This is 100 newtons at the rate of 25 newtons per meter. This is how UDL will be represented on a light beam, and this is how UDL will be represented on a beam of uniform cross section. Are these representations clear, guys? Clear, beta?
Yes, sir.
So when we use these words, they should not have different meanings for us at any stage. Wherever I have to change the meaning, I'll warn you upfront that we are changing the meaning from what we agreed in the first class. Okay, if I at all I'm doing it. Now, these are the only two types of forces we'll be dealing with. There can be weights like this. There can be non-uniform weights loaded on the beams, but we are not going to deal with them. We are only going to deal with 1 and 2. So guys, we have done what are the types of beams and what are the types of forces that can be loaded on the beam. Now, if you load anything on the beam and beam has a weight, then what should happen? The gravity of the earth should keep pulling the beam downwards, and the beam should go to the center of the earth. Unless the beam finds a support. For example, if the pencil or pen you are holding, if you just hold it a couple of inches above your table and release it, what happens? It falls down and continues falling till it finds support on the table. If table was not there, probably it would have found support on the floor. So it will keep falling towards the center of the earth because of the law of gravitation until it finds a support. Am I right, guys, in saying so, or anybody has any issues with that? The beam, if it does not find a support, will it continue moving towards the center of the earth, guys? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Now, beam can encounter, in our case, different types of supports. What can be the different types of supports that the beam can encounter? One can be point supports or knife edge supports, because knife edge is like a point. So point support or a knife edge support. That means the beam is supported at singular points, at those points. For example, if I have a light beam AB, it may be loaded as detailed in the question later on. And now suppose it is supported at both the ends over point supports. They need not be at the ends, guys. I'm just taking ends for the sake of easy discussion at the beginning level. So if they are supported on point supports at both the ends, then I'll represent the support like this. Is that clear, beta? Okay. If it was a beam of uniform cross section again and supported at both the ends over knife as supports, then this will be my beam of uniform cross section and it is supported over knife as supports. Then what are the other types of support? What could be the other type of support? Like your pen, which you dropped on the table, did it make us make contact at some definite points, or did it make the contact all along the length, guys?
All
Your
along the
pen
length.
fell. So that means in that case, your entire pen, the beam, pen is the beam out there. That means the beam is supported along its entire length. Now, is it necessary that it should be supported over entire length? No, it can be supported over part of the length also. For example, when you take a beam and you place it on two surfaces, like when you make a bridge. So what happens? The beam overlaps on one bank, it overlaps on the other bank, it is supported over a certain length on each side, and then, of course, it's hanging. So the other could be beam resting over a certain length. Certain length could be small length to the complete length. It can be any length. For example, if there is a light beam AB, and suppose it is resting on the, say, left half of it, that means left half A to the midpoint, it is resting on a plane surface. So I will represent it like this. It comes below the beam now. And suppose at B it continues to enjoy resting on a point support, then it can be like this. Or it can both be, it can be like this here, it can be like this here. They both need not be same length, they can be different lengths also. Or as you gave me the example of pen resting on the table, this is the beam and it may be resting on the complete surface. Now, instead of this light beam, if I want to make it a beam of uniform cross section, then my supports don't change, only the beam will change, guys. If supports remain same, then my beam instead of being a light beam has now become a beam of uniform cross section. My beam has now become of uniform cross section. My beam has now become of uniform cross section. Have you understood the types of supports we're talking about, guys? Point support or knife edge support, and support over a certain length. That length will be provided to you. And where is it supported? Those details the question has to provide you. Are the types of supports clear, guys?
Yes, sir.
Yes, sir.
Okay. Okay. So what before we start our discussion, what have we understood? We have understood certain terms we'll use to describe types of beams. We shall use certain terms to describe types of weights or forces loaded on the beam. And we shall also we have learned some terms to describe the type of support that shall the beam may experience. If you have any questions on this, and I have also described how we'll represent it, is it clear to everybody, guys? Yes or no?
Yes, sir.
Okay, good. So we move on with the next part of it. Cantilever, I'll come to it later and I'll skip it for the time being. Let's not mix up things here. Okay, guys. Now, in the beam, SFBM of the beam, the first thing you'll have to calculate is the reaction. After making the diagram, of course, the first thing you will do will be making the diagram. And the second thing you'll do is calculation of reactions. Now, please understand this. And if you have any problems, please unmute yourself and flag your concerns. Now, read the question. Will you all try to make a beam diagram for the question given here? Only the beam diagram with the support. When I say beam diagram, it includes the beam, it includes the weights, it includes the supports. Would you like to make based on our discussion over last 10 minutes?
Yes,
That
sir.
will also give, yeah, please make it. Then I'll make it, of course.
Thank you, sir.
Yeah, I think I marked it little off the distance. It should have been more closer to NDA. Anyway, so just little bit of error in marking the 30 Newton force. Is this what the diagram you made, guys? There are point forces, one at mid length, another 2 meters from end A, and you have point supports at end B. Let me make the correct diagram. Why I'm just with the wrong diagram here. Now I'll also speak as I'm making. It's a light beam, so I make a light beam. It's 10 meters long. It is supported over knife as support at the two ends. A, B is given in the question, so I name it. Supported over knife as supports. It carries a point force at the mid length, somewhere here, 50 newtons. And it carries, this is half, and so it will be somewhere here, 30 newtons. This distance, guys, is 2 meters. Up to mid length total would be 5 meters, so this will be remaining 3 meters. And lastly, it will be another 5 meters. Is this what you have made, guys, or something else? Tell me. Is this the beam diagram for this question? Because that is the first step. If
Yes,
you make
sir.
the beam diagram wrong, your entire question will go wrong because
Yes,
it will
sir.
guide you wrong. Because you'll be referring to the beam diagram when you are doing the question. So if you make a wrong diagram again, it will take you on a wrong track. Now, guys, why is this beam not going at reaching the center of the earth? Because of the supports, correct? Correct, Vita? This 80 Newton, 50 Newtons here, 30 Newtons total, there is a downward force of 80 Newtons acting on the beam. And this 80 Newtons should take the beam to the center of the earth by law of gravitation. But the beam is stopped. It's not going to the center of the earth. Why? Because it finds support at end A and at end B. Now, what happens then? When you have a support, like your pen found a support, where does the weight of the pen transfer when the pen rested on the table, guys? Where does the weight of the pen transfer?
The table.
On the table.
Table through the points of contact, right? Correct. So in
Yes,
my
sir.
case, this 80 newtons will be supported by what? It will be, or it will be transferred by to what? 80 newtons will be transferred to the support at end A and end B. So that means 80 newtons is putting a downward force at end A and end B. Why? Because the supports are at the ends. And guys, as per Newton's third law of motion, to every action, there is equal and opposite reaction. So 80 newtons, the beam is trying to exert on supports. As per Newton's third law of motion, these supports exert equal and opposite reaction. Let us say the reaction exerted at A is RA and reaction exerted at B is RB. Okay. Now, obviously, how much will be the total reaction? Total reaction has to match the downward force. So I'm sure all of you will agree RA plus RB in this example would be 80 newtons. Does anybody have any question on it, guys? Yes or no? Clear, beta?
Yes, clear.
Yes.
Okay. But we have to now find in this 80 Newton, how much is acting at A and how much is RB, how much is RA and how much is RB. So we need to learn to calculate the reactions. Now to calculate the reaction, guys, I again take you back to our discussion in moment of inertia where we took the moments. We took the moment of the ordinates, we took the moment of the areas. Here we'll take moments of the weights or the forces. What was the moment there? Moment was the area, volume, weight, or force, whatever it is, multiplied by the lever. What was the lever? Distance of the GC or the center of gravity from the reference axis. Now, what should I take the reference axis here? Which point should I take the moments about? Guys, technically, you can
Point
take
support.
moment about, yeah, you can take the moment about any point along the length from A to B. Technically, it's okay. No problem. You'll still get the answers. But to keep the calculation simple, what is recommended is, so it is a recommendation and a strong recommendation that you take the moments about one of the supports. Okay. Scientifically, technically, any support will do. Any point will do, right from A to B. You can take moments about any point. But to keep things simple, it is recommended that you take moments about one of the supports. Is my statement understood, guys? And you will understand in a while the advantage of taking moments about one of the supports. Whatever I said, is that well understood, guys, about which point preferably should you take the moments?
हाँ जी
Right, guys?
Yes,
Okay.
sir.
Yes.
So here I have a choice between A and B. I can take about anything, but since we have a habit of writing from left to right, so A becomes little more convenient to work with the figure, but B is equally good. Okay, so there should not be any problem. So let us take the moments about point A. Why? Because the beam is supported at A. So taking moments, and guys, this will be the first part of every question. First part of the question will be this, drawing the correct diagram. Second step will be to get the reactions. Taking moments about point A. And I'm not done yet. Okay, I'll write something more after this. Now, guys, moment of what? Moment of all the forces on the beam. Can you please look at the beam? And this is my rough work here. Can you look at the beam and tell me from left to right how many total forces are acting on the beam? Total count. 1, 2, 3, 4,
four
5, 6. There is
Four,
one
sir,
answer
four
four.
from Akshay. 4.
Four.
Can you please name the 4 forces from left to right? So can you name? I'm writing in rough.
RA
RA.
RA,
30
right?
Newton
W1.
30
50
Newton,
Newton
50
RB
Newton,
And RB.
RB. Anybody in the class who does not agree with this? This is the total number of forces acting on the beam. So each force will be causing moment. Okay. Now, guys, as far as RA is concerned, what will be the lever from point A about point A? 0.
0
So it is neither causing clockwise nor anti-clockwise. Now, see, if you hold hold your pen at one of the ends, guys. If you have a problem, hold the pen at one of the ends. Shall I put on my, let me just unshare the screen, and I'm putting on my camera. I'm in Bangalore right now, just managing it. Can you see me, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay, fine. Okay, now see, if you hold your pen like this is point A. Now, you have a 30 Newton acting downwards here. So if you hold the pen, is it trying to rotate the pen in the clockwise direction or anti-clockwise direction? Hold your pen if you have a doubt.
Clockwise direction, sir.
Clockwise. So that means this new force which is acting this way about A. So you have to take both force and the point in question. Okay, it cannot be only force. So this force is causing clockwise. So this moment is clockwise. Why? If the beam is rotating clockwise, what is rotating the beam? The moment. Which moment is it causing? If it is rotating clockwise, the moment caused is also clockwise. If there is a force acting like this, is it rotating the beam about A in the clockwise or anti-clockwise direction?
Anti-clockwise.
So obviously then the moment must be clockwise, must be anti-clockwise. Suppose I hold it at B, the other end. Then this force is causing an anti-clockwise movement about B. This force is causing a clockwise movement about B. Is the identification of clockwise movement and anti-clockwise movement clear, beta? Yes or no?
Yes.
Yes, sir.
I'm going off. I'm putting off the camera unless you have a doubt. Please clarify now. Yeah, tell me.
We are
Tell me.
taking clockwise and anti-clockwise by the end where we have the support.
It's not the end. You can be taking moments about any point here. Why only end, beta? End was just an example, right?
आई अंडरस्टैंड सर अब मैं बस इतना पूछना चाह रहा था कि आप जो क्लॉकवाइज और एंटी क्लॉकवाइज बोल रहे हो ना तो वन एंड इज गोइंग क्लॉकवाइज एंड अगर पेन का एग्जांपल ले तो वन ऑफ एंड इज गोइंग क्लॉकवाइज अनदर वन इज गोइंग लाइक it can be seen that
no. If you're taking moments about A, then hold at A, na. Then how is end A going clock? Then which about A which direction is the pen rotating? Clockwise, no? Yes or no? Any rotational thing has to be about a point or an axis, no? Yes or no?
yes sir.
So it is the point or the axis is the point of reference about which you are taking the moments, right?
yes sir, correct.
Okay,
ठीक है, okay sir.
Let's go back to the screen sharing. Please confirm the screen is again visible where I'm writing in it. Okay.
Yes, sir.
Now I'll just do it one time and then we don't have to mess up our diagram. This is not what I expect you to do every time. You'll have to visualize. You see, we have decided to take moments about which point. We have decided to take point about point A. So in a way, I have seized the point A. I'm sure if you see that now, if you hold at A, this is going to cause clockwise movement. This is going to cause clockwise movement about A. And this is going to cause anti-clockwise movement about A. Yes or no, beta? Am I right?
Yes.
Okay. So in the diagram also you can figure out. So taking moments about A, and since some moments are clockwise, some moments are anti-clockwise, instead of writing clockwise and anti-clockwise, we can introduce a sign convention. And I'll write it here. Taking clockwise as positive and anti-clockwise as, you can take down this statement because you will be writing this every time. Anti-clockwise as negative. Point can be different. Here it's point A. Every time may not be point A. It's okay. Now, there are four forces. 1, 2, 3, and 4 which are listed in the box. there are 4 forces, there will be 4 moments. As far as force RA is concerned, its lever about A is 0. So the moment will be RA into 0. Now, whether you put plus before it or minus does not make any difference because 0 is neither positive nor negative. So you can put whatever you want. Is the moment of RA about A clear, class? Yes or no?
Yes, sir.
Yes, yes. Got it.
Now, 30 newtons is causing clockwise movement, and as per the convention that we have written on top,
Yes.
it will become plus, and the force is 30 newtons. Its lever from A is 2 meters, so it is plus 30 into 2. Correct, guys? Okay.
Correct,
Next,
sir.
so we have taken moment of this, we have taken moment of this. Next, we have to take moment of 50 newtons. Now, 50 newtons, I look at the diagram about A, it is causing clockwise movement. So plus 50 into what? What is the lever from A? 5 meters. Correct,
5.
class? And RB, we said, is causing anti-clockwise movement. So minus RB into lever from A will be 10 meters. Are these the 4 moments of these 4 forces, guys? Yes or no? Please tell me.
Yes,
Yes.
sir.
Okay. Now, guys, suppose the total anti-clockwise moment was more than the clockwise moment. What will that do result? What will this mean? Suppose the total anti-clockwise moment was equal to the was greater than the clockwise moment. Then what will it mean? It will mean that the beam should be rotating about A in the anti-clockwise direction. Yes or no? Because anti-clockwise you're saying is more than the clockwise. So resultant will be anti-clockwise and it will make the beam rotate in the anti-clockwise direction about A. Have you understood what I said and are you in agreement? Tell me, guys. I'm saying suppose the total anti-clockwise moment experienced by this beam about A was more than the total clockwise moment, then what will be the resultant? Resultant will be anti-clockwise. And what will that signify? That will signify that about A, the beam is rotating in the anti-clockwise direction. Am I right, guys? Yes or no? Correct?
Yes.
Yes, sir.
Or vice versa? If the resultant clockwise moment is more than the resultant anti-clockwise moment, total anti-clockwise moment, the resultant algebraic sum will be clockwise. That means the beam should be rotating in the clockwise direction. So beam, if there is a imbalance between the total clockwise moment and total anti-clockwise moment, then beam cannot be at rest about A, then it should be rotating about A. Am I right, guys? Yes or no? Correct?
Yes, sir.
But is our beam rotating about A or is it in equilibrium? It is in
No.
static equilibrium.
Equilibrium.
When will this happen? When the total clockwise moment about A equals the total anti-clockwise moment about A. Then only the beam will not be rotating about A. So since the beam is not rotating, you don't have to write, you have to tell yourself. As the beam is not rotating about A and is in static equilibrium, therefore the resultant of all these movements should be
80
zero.
Newton.
Should be zero.
80.
Why 80? 80 is RA plus RB, beta.
Hanji.
That they are forces. 80 Newton is a force. This equation is for the moments. This equation is not in force.
Okay, sir. ठीक है. Correct.
This is the equation of the moments, and that 80 newtons is force, right? They are two different things altogether, right? The beam is not rotating and is in static equilibrium. Therefore, the algebraic sum of clockwise and anti-clockwise moments about A must be zero. Am I right, class? Yes or no? Anybody has any questions? Clear? Okay. Now, guys, now you can see why did I recommend taking moments about one of the supports. If you take moments about one of the supports like this, in this case, we took about A, then what happens is there were two variables in our equation, RA and RB. the term containing RA has become 0. That is why it was recommended that you take moments about one of the supports. And when you solve this equation, what does it give you RB equal to? It gives you RB equal to 31
31
newtons.
Newton.
Please let me know for the last time if anybody has any questions up to this point, because these will be the part of every question. You cannot keep, wasting your time on this point every day. If you have any concerns about it, if you don't agree, I have explained with the basic science concepts so that it does not become a random forced process. One way of learning is force yourself, I'll do this, I'll do this, I'll do this. Other is link it to science that you know. Okay, it's all connected to physics that you have done, guys. Nothing more, nothing new. We are not violating any physics law. Everybody agrees RB is 31 newtons and all the explanation given above.
Yes, sir.
And this implies RA plus RB is 80 newtons. So RA will be equal to 80 minus 31 equal to 49 newtons. So this way, what have we been able to achieve? We have been able to achieve the split of 80 newtons into RA and RB. And I'll put these values back on diagram. How much is RB? 31 newtons. How much is RA? 49 newtons. This brings us to end of the second step. The first step was making the diagram. Second step was calculating the reactions. Are these two steps well understood, guys? You can try it about any point. Now you'll say, sir, if I take a point here and take the moments, what will happen in the expression? I'll have RA and RB both remaining. Then you will have to use this equation and solve by simultaneous equation, which will be lengthy process unnecessary. Therefore, it was strongly recommended that you take moments about one of the supports. Is that clear now? Clear, guys?
Yes, sir.
Okay. Any more questions up to this point? Please take a 30 seconds to 1 minute relook at what we have done. And if anything is not clear here, let me know. Sahil Yadav, is it making sense?
Yes, sir.
समझ में आया? Okay, good. Can I continue, guys, if it's okay with everybody?
Yes, sir.
Yes,
Okay,
sir.
let me see what is on the left. Okay. Now, I'll draw this diagram with reactions marked on the next page, and then we'll see what do we mean by shearing force. Okay. It's the same question which is we have just discussed. Only thing is now I'll not explain to you how the diagram is made and how reactions are calculated. That we have already done on the previous slide here. That we have already discussed here, guys. This we have already discussed, and now I'm carrying forward this diagram here. Guys, I have reproduced the diagram that we just finished with on the previous page with the reactions picked up as we calculated. All good up to this point? Okay. Let me just name these points for the purpose of discussion. You can name them whatever, guys. There's no hard and fast rule for naming them. Okay, you can name them X, Y, whatever, C, D, D, C, whatever you want to. No problem. Now, guys, take any point along the beam, take 2 points rather, and tell me where would you like to take the 2 points between AD, DC, CB. First point, where would you like to take? Anywhere. Which segment, which part will you like to take a point?
Between AD, sir.
Okay. Okay, let's say here is X. Does not have to be midpoint, it can be any point for SF, doesn't matter. Tell me where would you like to take one more point, Y?
Between DC.
DC, okay, let's say here is point Y, doesn't matter. Now guys, what we'll do is we'll do the algebraic sum, or let us see what is the resultant force acting to the left of X. What is the resultant force acting to the left of X? What are the forces to the left of X, guys? If I come from left to X, how many forces are there? There is only one force, 49 newtons, which is acting upwards. Am I right, guys? Correct, beta?
Correct, sir.
Let me see the forces which are active. You don't have to draw these arrows. I'm drawing it just for the sake of clarity one time. There are 3 forces to the right of right of X. Now, if I start from the right hand, there is 31 Newton, which is acting upwards. Then there is 50 Newtons acting downwards. And there is another 30 Newtons acting downwards. What is the resultant of these 3 guys? Is it again 49 Newtons? And this time acting downwards? Yes or no? Please confirm.
Yes.
Yes, sir. 49.
Where? Does everybody agree what I have done, guys? I have done the audit of the forces to the left of point X, which was randomly taken point X, and also the audit of the forces randomly chosen point X to the right of it. And what was the result we got? On one side, we got it 49 newtons upwards. On the other side, we got it 49 newtons downwards, the resultant force. Does everybody agree? Yes or no?
Yes, sir.
Okay. Now, we will do the similar exercise at point Y. What are the forces to the left of Y? We have 49 newtons acting downwards, and we have upwards. My mistake. I stand corrected. 49 newtons upwards and 30 newtons downwards. So what is the resultant of forces to the left of Y, guys?
19.
It's 19 newtons upwards, correct? What is the resultant of forces to the right of Y? We have 31 newtons upwards and we have 50 newtons downwards. What is the resultant? Again 19 newtons, but this time it is downwards. Does everybody agree with what we have done? Yes or no? Now, what do you see in these 2 cases? And if you take any, and they were randomly chosen points, they were not selected points, right? That the force numerically on each side of the point, the resultant force on each side of the point is numerically same. Only thing is, if it is upwards on one side, it's downward on the other. And if it was downward on one side, it will be upward on the other side. What do we see at Y? We see the same thing. The resultant of the force on both the sides is same, but these up and down signs are reversed. And if you take any other point wherever you want, you can take wherever you want, you will get the similar outcome, that the resultant of forces on each side will be same. Only thing is, if it is upward on one side, it will be downward on the other, or if it was downward on one side, it will be upward on the other side. Have you understood what I'm saying, guys? Yes or no?
Yes, sir. Means the whole beam at any point is at equilibrium.
No, this is not about equilibrium. This is the resultant of forces on both sides is the same. This is not causing. Equilibrium will be caused by moments. Rotation is caused by moments, not by up down forces, right, beta?
Okay, sir.
Right. And the total beam in equilibrium is because total reaction is equal to total weight, right? 80 newtons, 80 newtons. That is preventing it moving from up and down. And the resultant moments being zero is preventing it from being rotating about any point, right? But here you have, what do you see? The resultant forces on either side of a point numerically are the same, but their directions are reversed, correct? Correct, class? Correct, guys?
Yes, sir.
Yes.
Okay. Now I'll come again on camera.
Yes, sir.
I'll come again on camera. I'm unsharing the screen. I'll spotlight myself. Okay. Okay. 1 second. 1 second. Did I exit the spotlight? No. Is it on spotlight? Let me just do exit spotlight and re-spotlight myself. Okay. Fine. Spotlight for everyone. Okay. Okay, guys. Now you see, this is your pen. Let us say where this white and black portion is separated. Let us say this was point X. Now on one side of point X, let me just create some space on my, let me be able to see the values. Yeah, okay. Now, guys, it is downward. Okay, fine. Now you see here, 49 up downwards on this side. Okay, fine. Now you see, guys, this was point X. Now, if I hold this beam like this at X, okay, if I hold this beam like this, then what are the forces on this side trying to do at X? At X, they are trying to move the beam down from here because of these forces by how much? By 49 newtons. They are trying to move it downward. Yes or no, beta? Am I right?
Yes, sir.
Yes, sir.
This part of the beam at X is being pushed down at X by 49 newtons. So now, if the beam is weak, what will happen? The beam will break here. If this point at X, the beam cannot withstand 49 newtons, then the beam will break. If the beam is strong, it will not break. Now let me hold at X on the other side. What are the forces on this side at X trying to do? They are
49
trying to
pushing upward.
pushing up. So whether I support this side or I support this side. At X, a force of 49 newtons is trying to break the beam at X. Yes or no? Am I right? Correct, beta?
Yes, sir.
Yes,
A
sir.
force of 49 newtons is trying to break the beam at X. Similarly, let us say now, I've done like this. Let's say now this point represents Y. I've taken the white on the other side. If I hold this side, then at Y, 31 newtons is trying to break the beam at Y. Yes or no? Upward or downward? My screen is, the diagram is hidden behind. I think it will be 31 downwards, right? So this is trying to break the beam at Y. A 31 Newton force is trying to break the beam at Y. Do you agree with me, guys? Yes or no? By pushing this portion and exerting a 31 Newton force at Y to try to break the beam. Yes or no? Correct, beta? Am I right, class?
Yes, sir.
If I hold it at Y like this, then 31 newtons is again trying to break it by pushing this part upwards. So can I say before I put off the camera that at X, 49 newtons is trying to break the beam. At Y, 31 newtons is trying to break the beam. Do you agree with me? Yes or no?
Yes, sir.
Class,
Yes,
anybody has I'll be going off camera, guys. If you have anything, because I still have the pen in my hand, let me know if there's any issue.
So why is 19 Newton? 19 newtons of force is creating to break the beam.
Okay, 19, not 49, 19. Okay. At X. At X, it is 19.
On
Acha,
Y,
okay. Okay, values may be different, but have you understood the concept? Fine,
Yes,
because
sir.
my diagram is hidden. That's why I couldn't see it, right?
Yes, sir.
Okay, my diagram is hidden behind this window. Okay, since your not screen is not shared, so you are able to see. I can't see the diagram. You can't see the screen. My screen is hidden by with this MS Team window has popped up because of the camera, right?
Right.
Okay. Is that clear, guys? Do you agree that there is certain force which is trying to break the beam at X, which was the algebraic sum of the forces, and there is another value of the force which is trying to break the beam at Y, correct? Whatever the value, whether 19 or 31 or whatever, no issues.
Yes,
Clear,
sir.
class?
Understood, sir.
Okay, so I'm putting off the camera and going back to the screen share. Okay. So what have we just agreed when I was on camera? That at X, 49 Newton is trying to break the beam. At Y, 19 Newtons is trying to break the beam. So at X, in this case, breaking force at X is 49 Newtons. At Y, breaking force at Y is 19 Newtons. Whether it is moving up or down, it's trying to break. Guys, in English, another name for breaking is shearing. Shearing means breaking. So this force which is trying to break the beam at X, 49 Newtons, is the shearing force at X. This 19 Newtons at Y, which is trying to break the beam, is the shearing force at Y. So what is the shearing force? If you see this description that we have just done, how did we get this 49 Newtons? We got it as an algebraic sum of either adding all the forces algebraically to the left of it or adding all the forces algebraically to the right of it. Am I right, guys? So with this small example, simple example, do you agree with me if I may say that SF at any point is the algebraic sum of all the forces to any one side, whether to the left or right, any one side of the point in question. Do you agree with me? Yes or no? Point in question means not in the question paper, point under discussion or point in discussion. Otherwise, somebody will say, where is it written in the question? SF at any point is the algebraic sum of all the forces to any one side, whether to the left of it or to the right of it, of the point in discussion. Earlier, the point in discussion was X. So to the left of it also, the force was 49 Newtons. To the right of it also, the algebraic sum was 49 Newtons. So 49 Newtons is the shearing force at X. Likewise, at Y, the point in discussion, the shearing force, whether you do one side, left side, or you do right side. Why should you do both sides and waste your time when you're going to get the same value? You could just be doing any one side, and the value will be 19 Newtons at Y. Have you understood the basic concept of shearing force, guys? And how can we obtain in a beam like this? By algebraically adding all the forces to any one side of it, right? Clear, class?
Yes, sir.
Clear, class?
Okay.
Okay. But there is a very small issue now here. What is the small issue? Small issue is that if I ask the class what is the shearing force at X, then some of you will do from left to right. That means you will go reach X from left to right. What do I mean by left to right? Let me take the blue marker. Or let me take some other marker, black or something. Yeah, let me take the black marker then here. Okay. Some of you may do like this. That means you may reach point X and I say left to right. Those who go from left to right, they will give me an answer of 49 newtons upwards. And those who reach X from right to left like this I'll call as right to left. They will also give me 49 newtons, but they will tell me, sir, it is downwards. So where both sides are giving me numerically the same value, there will be a discrepancy in the sign. One will say upwards, other will say downwards. Though whether it is upwards or downwards, whether one part moves down and breaks or the other part moves up and breaks, it does not change the braking force. It does not change the shearing force and its effect. Okay, so this is inconsequential whether you are saying it is going up, acting upwards or downwards. However, to streamline and ensure that everybody gives the same answer, a sign convention is introduced. A sign convention is introduced for shearing force. Now, guys, there are only two options to reach point X or point Y. One is you go from left to right. That means you start from the left end and reach point X, or you start from the right end and reach point X, right to left. Now, to make sure that both sides give me the same answer, a reciprocal sign convention is intentionally introduced. So we'll not say upward or downwards, we'll replace it with plus minus. When you go from left to right, guys, the upward force will be taken as positive and downward force will be taken as negative. And since we want to achieve the same end result, those coming from right to left will have to follow a reverse sign convention. That means for them, upward will be negative and downward will be positive. So if you remember one, the other one can just be made reversed. And why has this sign convention been reversed? So that at X, either both get plus 49 or both will get minus 49. And this reversal of the sign convention will ensure that at Y, either both will say plus 19 or both will say minus 19. Have you understood the need of sign convention and what is the sign convention, guys, here for shearing force? Clear? Clear, beta? Yes or no?
Yes.
So now, those who are going from left to right to X, there is only one force 49, which is upwards. Left to right upward is positive. So it is plus 49. Those who are coming from right to left, 31 newtons is upwards. Upward forces, you see right to left is negative. 50 newtons is downwards, positive. 30 newtons is downwards, positive, right to left. The resultant will be again plus 49. So now both will give me the same answer. That is the advantage of the sign convention. So whereas the shearing force at any point still remains the same. It's the algebraic sum of the forces to any one side, left end to the point in question, or right end to the point in question. That means left to right or right to left. Only thing is, now instead of up and down, we are saying we'll talk in terms of plus minus based on this sign convention. Am I clear what I have said, guys? Please let me know if there's a concern. Clear, beta? Class, is it clear?
And you said,
Okay. Now, what will we basically do? We will learn to draw now the SF diagram. We learn to draw the SF diagram. Guys, when you learn to draw the GZ curve, what did you do? You got the GZ values at certain angles of yield. You plotted those values and joined those points to get the curve. Likewise, we will calculate the shearing force at some different points along the length of the beam, plot them, and whatever we get will be the shearing force diagram. Whatever we get will be the shearing force diagram. If you see this very example, shearing force at X is plus 49 and shearing force at Y is 19. So, right, it's plus 19. So that means shearing force may change from point to point, may not change from point to point. So therefore, to be able to get a diagram which reflects the shearing force at any point along the length of the beam, we draw a diagram, and that diagram is called as the shearing force diagram. Now, what will I do first? I will draw it in a very crude way by taking 10, 11, 12, 13 points along the length of this beam and then plotting them. And having seen the shape of the curve that we get, then we'll come to a formal shortcut method of getting the curve so that you are convinced that yes, it will give you the same result. Okay. But guys, tell me one thing. Is it sensible that every day we keep changing the sign convention? Because sometimes one morning I got up and I said, I'll take from left to right. Next morning I got up, I said, today I'll work from right to left. Will it make our lives easy or difficult? It will make your life difficult. If your normal instinct is to work from in the forward direction, then yes, you can work backwards, but you will have to be careful when you walk backwards. Yes or no, beta? Because you may trip, you may step into a pit. Why? Because you have a normal instinct, your vision is in the forward direction, and your normal walking is in the forward direction. Does that mean I can't walk the reverse way? Yes, I can. What do I need to do? I need to be careful. So, guys, normally the language in which we are studying today, in which we are talking, do we write from left to right or right to left?
Left to right.
Left to
So
right.
right.
And I'm sure whenever you look at the board, because it's the instinct, because you're tuned to this. So when you look at the board, your normal attention it catches is from left to right, correct? Correct. So
Correct.
so let's agree within the class that as far as possible, I will always work from left to right. And when I work from left to right, what does my sign convention says? Upward forces are positive, downward forces are negative, so that every time I'm not struggling for the sign convention. So in the class, in the normal course of action, let's agree that we'll always work from left to right, unless there is a situation where I have to walk backwards. That means where maybe I am forced to work from right to left. That time what will I tell myself? What do I tell myself when I walk backwards? That I need to be careful. So if I have to tomorrow work from right to left, I'll tell myself, boss, sign convention has to be reversed. Be careful. Write down the sign convention and reverse it. No problems. But why every day waste time in sometimes figuring out is upward force, are they positive, is downward negative or positive? Because every question, every minute, if you keep changing the directions, then you are going to mess it for yourself, right, guys? Technically, there's no change, no effect, but it's going to mess your life. So, do we all agree that in normal course, as far as practicable, I'm not saying always and you can't change. No, I have not said so. As far as practicable, do we agree that in for working shearing force at any point, we'll take the points from left to right? That means to the left of the point under consideration, right, boy, guys? Do you agree? Okay, right, guys? We'll go from left to right, correct? And when we go from left to right, upward forces are positive, downward forces are negative. So it makes it easier, because easier to remember, easier to implement. Now, following this, let me draw the same diagram with reactions, and I'll mark some points, and we'll calculate the shearing force at those points by taking into consideration the forces to the left of it from left to right. And when we go from left to right, upward forces are positive, downward forces are negative. So we'll not use up and down terminology, we'll use plus minus signs. Let me redraw the diagram here. And then after we see the diagram, then I will tell you how to make it more effectively and with lesser effort. But guys, it's also important to understand all that is being done. Then only that shorter method will start making sense to you. This part of the diagram needs no further explanation. We have already done it. You have point C, it is 50 newtons here. You have point D, which is 30 newtons. You had RA, which was 49 newtons. And you had RB, which was 31 newtons. This distance is 2 meters. This distance is 3 meters. And this distance is 5 meters to a scale. I hope this diagram is not a concern with reaction posted on it. Correct, Peter? Now, I'll select some points, a number of points, sufficient number of points on this beam, which is just about 10 meters in length. And then I'll ask you, with your help, I'll write down the shearing force at those points. Okay. Let's say there is point 1. Then there is point 2. Guys, what is point 1 and point 2? Point 1 is just to the left of point A. So if you have point A here, the very next point to left of it, very next point is 1. And the very next point to right of A is 2. That means 1, A, and 2 are 3 adjoining points. They are 3 adjacent points. There is nothing in between them. Is that clear, beta? Understood? Okay. Then I'm taking some point 3 anywhere. It can be anywhere along the length between AD. Then likewise, I'm taking point 4 just to the left of D. I'm taking point 5 just to the right of D. That means point 4, point D, and point 5 are 3 adjacent points. Then I'm taking point 6, point 7, point 8 just to the left of C, and point 9 just to the right of C. Then I have 10, 11, 12. I have 13 just to the left of B, and 14 just to the left of B. That means 13, B, and 14 are 3 adjacent points, and there is no point in between these 3 now. Have you understood what have I said, beta?
Yes.
Now, focus from left to right. Upward forces are positive, downward forces are negative. Guys, to the left of point 1, are there any forces? Yes or no?
0.
No, sir, 0.
So shearing force at point 1 is 0. Yes or no? Am I right, class?
Correct, sir.
Correct.
Okay. What is the shearing force at point 2? Just uncover, go up to 2, see what are the left forces to the left of point 2.
49
plus 49 plus 49. Correct? This is the shearing force then. Does everybody agree with it? Yes or no?
Yes, sir. Agree.
What is the shearing force at point 3, class? What you can do is take this 49, which is already up to 2, and see between 2 and 3, is there any new force coming in?
No.
No, sir.
So the change is 0. So shearing force will remain plus 49, right, beta? Am I right?
Yes. Correct, sir.
I go to point 4. Up to 3, the total force resultant is plus 49. Is there any change between 3 and 4?
No, sir.
No, sir.
So this remains plus 49. Guys, I don't want to rush. Anybody has any questions up to point 4? Please let me know. Go to point 5. Up to point 4, it is plus 49. Is there any change between 4 and 5?
Yes, sir.
Yes.
Minus
No.
30.
Minus 30.
Minus 30, becoming plus 19 now. Guys, is there any change from 5 to 6?
No.
No, sir.
Is there any change from 6 to 7?
No, sir.
No.
So that means at 6 and 7, this will remain plus 19 as there is no change. Am I right, guys? Yes or no?
Yes,
Correct,
sir.
sir.
Yes.
Better, if you're not talking to me, please mute yourself. Is there any change from 7 to 8? Please let me know.
No, sir.
No, sir. 7 to 8. No change.
Very good. It's plus 19. Very good. But 8 I have intentionally written separately. Don't think it was a miss out. I wrote intentionally separately. What will be the shearing force at 9? Plus 19, and then there is minus
Minus
50
50.
coming to minus 31, right?
Correct, sir.
There is no change between 9 to 10, 10 to 11, 11 to 12. So that means 10, 11, 12. It remains minus 31. Am I right, guys?
Correct, sir.
Then at 13, there is again no change. It's minus 31 plus minus 0, minus 31. How much does it become at 14? Minus 31 plus
0.
31 becoming 0. Guys, if anybody has not understood what I have done, please clarify. Does everybody understand the writing of these shearing forces from point 1 to point 14 taken on the beam?
सर
Tell me.
सर आपने मतलब 14 क्यों लिया पॉइंट
वैसे ही रैंडमली बेटा, 10 मीटर बीम थी, मैंने 14 ले लिया, तुम 16 ले लो, तुम 18 ले लो, राइट?
ठीक है प्लीज मुझे 5 नंबर का बता दोगे 5 नंबर का 49 माइनस 30
नहीं, what is the shearing force at 4?
सर शेयरिंग फोर्स है फॉर इज प्लस 49
Firstly, up to 4, are you in agreement?
यस सर
Sure?
यस सर
Correct?
49 यस
Okay.
श्योर
From 4 to 5, what is the change? Look at the diagram. Don't look at the
Yes.
table below. Look at the diagram. What is the change between point 4 and point 5?
4 and 5 सर डाउनवर्ड फोर्स है माइनस 30
So, if all the forces up to 4 were minus 49, and now a minus 30 change is happening, so what will be the shearing force at 5? It will be minus plus 19.
माइनस 30 यस सर और मुझे सर 3 नंबर का बता दीजिए अभी 3 नंबर का आ रहा है कि 49 और
Okay, how many? First, tell me. Look at the diagram.
Yes,
What
sir.
what is the algebraic sum of forces to the left of point 3? First, tell me your.
लेफ्ट हाँ सर पॉइंट ए इज 49
What? No, answer my question. Don't say point A. What is the algebraic sum of forces to the left of point 3? Is my question. Don't
लेफ्ट
talk
ऑफ
about point A. Give me the algebraic sum. Don't name the any other point now in between.
1 and 2
What is the algebraic sum of forces to the left of point 3? I'm not asking points. I'm saying what is the algebraic sum of forces to the left of point 3?
अपवर्ड फोर्सेस सर अपवर्ड फोर्सेस
कितना यार अपवर्ड? पहली बात तो अपवर्ड डाउनवर्ड हमने बात ही नहीं करना. Why are you bringing upward downward now? It has to be spoke.
49
Only 49 you'll say. There is no sign convention. You don't respect the sign convention, Samir.
yes plus 49 सर plus 49
कहाँ पर? 3 पे. Is it?
Yes, sir. Right.
सो 3 पे प्लस 49 है, यहाँ तक ठीक है,
हाँ।
यहाँ भी कुछ प्रॉब्लम है?
ठीक है, समझ में आया। ठीक है।
फिर तो अगर 3 तक 49 है तो इंस्टेड ऑफ सी व्हाट आई एम सेइंग इज, अगर 3 पे प्लस 49 है और मुझे 4 पे चाहिए, तो व्हाई शुड आई स्टार्ट अगेन फ्रॉम 0? भाई 3 तक मेरे पास प्लस 49 आ गया तो इसके बीच का चेंज लगा दूंगा ना उसमें, राइट?
हाँ हाँ।
तो 3 और 4 के बीच में कोई चेंज है, नया फोर्स आया है?
नहीं सर।
तो फिर अगर 3 पे प्लस 49 था तो 4 पे भी क्या रहेगा? प्लस 49 ही ना,
+49। ओके, बराबर।
करेक्ट? अब आगे देखो कहाँ डाउट है, अब आगे देखो।
ठीक है, समझ में आया था। मेरा वही डाउट था कि 3 पे फिर माइनस क्यों नहीं गया
अभी
30,
देख
ये मेरा डाउट था, लेकिन समझ में आया।
फटाफट देखो कहीं और पे है,
ओके सर।
कोई और पॉइंट
नहीं
है?
डाउट नहीं। नहीं सर, नहीं, कुछ डाउट नहीं, समझ में।
Okay, okay. Now, guys, see at point 1 and 2. At point 1, it was 0. At point 2, it is plus 49. Do you agree with me? Correct?
Yes, sir.
Guys, if on one day you had 100 rupees at the end of day 1, and at the beginning of day 3, you are left with 40 rupees, then when would you have spent 60 rupees? On day 2? Yes or no? Correct? I'm saying on day 1, if you had 100 rupees, end of day 1, and at the beginning of day 3, you are left with 40 rupees. So, जो 60 rupees वे किस दिन खर्च किए? They
Second
would have
day.
been spent on the second day. Correct? Yes or
sir.
no?
Yes, sir.
Why? Because first day, third day, and second day are adjoining each other. Correct, beta? Am I right?
Correct.
My 3 points, 1, A, and 2 are 3 adjacent points as per what we took. So if the shearing force is 0 at 1 and plus 49 at 2, where would this change actually take place? It will change, the change will take place in between the two. And
Yes,
what
sir.
is in between the two? In
At
between
A.
the two is point A. Yes or no?
A.
Correct. So that means whatever has happened at 1 and 2 actually represents what has actually happened at point A. Does everybody agree with me? Yes or no?
Agree, sir.
Yes, sir.
Class?
Yes, sir.
Likewise, whatever has happened at 4 and 5, look at the diagram. Effectively, that has happened where? That has happened at point D. Yes or no?
Yes, sir.
4 is just to the left of D, 5 is just to the right of D. That means whatever change is taking place between 4 and 5 is actually happening at D. Am I right? Correct, class? Yes or
sir.
no?
Correct.
Yes sir.
Then what does the change at A and 9, 8 and 9 represent? That means what is actually effectively happening at point C? Yes or no?
Yes, sir.
And likewise, the change between 13 and 14 is effectively what is happening at B. Guys, please review it and let me know if there's a concern. That means actually at A, the shearing force changes from 0 to plus 49. At D, it changes from plus 49 to plus 19. At C, it changes from plus 19 to minus 31. And B, it changes from minus 31 to 0. Do you agree with the logic that I've given? Yes or no?
Yes, sir. Agree.
Based on this, now I'll draw the SF diagram for this simple question. In the SF diagram, we'll take the length of the beam on the x-axis and we'll take on the y-axis the SF. We change the color of the bar. Since the other line is also blue, that will create some confusion. See guys, this is my x-axis which represents the length of the beam. This is my y-axis which represents the shearing force. What are the units of shearing force? Unit of force in this question are newtons. What is this end? A. What is this end? B. Obviously, midway between them is point C, and 2 meters from here is D. This is 2 meters to a scale. This is 3 meters to a scale. This is 5 meters to a scale. I graduate my y-axis depending on my values. I have plus 49 values and minus 31 newtons. So let us say plus 10, 20, 30, 40, 50. What did I do? I missed out something. Okay, 10. No, okay. 40, 30, 20. Sorry, 20 and 10. I wrote it. 10 and 0. Likewise, minus 10, minus 20, minus 30, minus 40. Correct, guys? Yes or no?
Yes,
I
sir.
have calibrated the x-axis. So guys, what are we basically looking at now? What we are looking at is now drawing the shearing force diagram. Okay, so we'll draw the shearing force diagram now. I'll change the color to, let us say, blue. I can change. Yeah, blue will stand out now, no problems. Okay. Guys, what is happening at A? Can you tell me? At A, what is the shearing force changing from 0 to plus 49? Am I right?
49.
See here. Here.
Correct,
Yes.
sir.
So it changes from 0 to plus 49 here, like this. What does it remain to 0.3? It remains plus 49. And what does it remain up to 0.4? It remains plus 49. And what is 4? 4 is effectively D. That means it remains plus 49 effectively up to D. Am I right, guys? Yes or no?
Right, sir.
And then at D, it changes from plus 49 to plus 19. Plus 19 would be somewhere here. So it changes from plus 49 to plus 19. Correct, beta? At
Correct,
D.
sir.
Then it remains plus 19 up to C as per the calculated values. And at C, it changes from plus 19 to minus 31. Minus 31 would be somewhere here. Then it remains minus 31 up to B. And at B, it becomes from minus 31 to 0. Do you agree that this blue that I have drawn here is the shearing force diagram, guys, for this question? Simple? Yes or no?
Yes, sir.
So this is the shearing force diagram for this simple question. And how did we get it? We got it through a very, very crude method, taking random points and doing all that, which basically will always be time consuming and more difficult. We will try to standardize the process and streamline and reduce the number of points. But we'll do that only if everybody is in agreement with this diagram up to this point, guys.
Yes, sir.
Everybody is good up to this point? Huh? Tell me.
Understood, sir.
Okay. Anybody else in the class who has any questions? Okay. Now, what I'll do is I'll do this question in a informal way. And what we'll do is we'll do this question. Of course, it's a recap of the points, but I'll do it here. Okay, let me do this question completely from end to end. And today I'm only focusing on shearing force, guys. You must be thinking that question does not talk of BM. Why? Because unless you know the shearing force properly, you will not be able to work the BM. Because the shearing force will be further used for calculating BM. So if your shearing force is wrong, your BM is not going to be correct in any case. Okay. So you need to be very, very clear about shearing force. So guys, what will be the first step? First step is you will draw the beam diagram. Reading this question, I'll draw the beam diagram and stop. Okay, it's here. Okay, it's here. Okay, okay. No, this is a different question. It's here. I'll draw the beam diagram and stop, and you'll please appreciate that when I say beam diagram, I only meant up to this point. Akshay, mute kar le beta, please. Mute kar lo. Thank you. Now, guys, this is what I meant by the beam diagram. Is that clear to everybody?
Yes, sir.
Okay, so the first thing you've done is, I'm writing the points here. Draw the beam diagram. Then I mark the reactions RA and RB. Second point is calculate the reactions. Okay, I'll do that step again. I've already explained. I will not take time, but if anybody still wants to clarify, you can speak, and you also know then what to write. Now, taking moments about A. We have already explained this. Clockwise as positive and anti-clockwise as negative. I still write in rough the four forces, but I've already explained, so I'm just cutting short. RA into 0 plus 30 into 2 plus 50 into 5 minus RB into 10. And since the beam is in equilibrium and not rotating, the algebraic sum will be 0. When I solve this, I get RB equal to 31 newtons as RA plus RB is equal to 80 newtons. This implies RA is 49 newtons. So guys, first point completed, second point completed, and now you'll put these reactions on the diagram. 49 newtons and 31 newtons. The step 2 is completed. Anybody has any questions on step 2, guys? Step 1 and 2 is clear, guys?
Yes, sir.
Now, the third step is, now beam diagram assumes importance, right? By looking at the beam diagram. So if beam diagram is wrong, third step will be wrong. Identify minimum points for SF table. That means instead of 14 points, what is the minimum number of points I should take for making the SF table? Why? When the word is minimum, not maximum, guys. If you miss out these points, you will not be able to shape your BM diagram. You take 1 point extra, that is not a harm if you continue doing correctly after that. But if you miss out any of these and take lesser than this, then that will send you in a spin. So the word here is minimum points for SF table. Now, how will you identify the minimum points for SF table, guys? Your first criteria is take endpoints. Second, take points where point forces act. I'm not saying load. I'm not saying downward. I'm not saying upward. I'm using a generic term, point forces act. They could be downward forces, they could be upward forces. And C, I will add here later. So if you're taking notes, leave some space here for some addition later on. In this case, only these two criteria will apply. If you apply these two criteria, guys, how many points? Just name the number of points which we'll have to take to meet both these A and B. How many points total?
4 points.
4 points. So I'm sure you mean the ends, and let me name these points as C and D. So do you mean A, D, C, B? Yes or no? Or you meant some other point also? Guys, I'm looking at the diagram and I'm identifying what is the minimum number of points I need to take to make the SF table. Is that clear?
Yes, sir.
Okay. Guys, why have A and B qualified? Can somebody tell me? Why and
Because
why
they
the
are
point?
endpoints, sir.
And
Because
points.
and which are the points where we have the point forces? Can you tell me all the points where we have point forces?
Sir, D.
C and
Speak up.
D.
We have point D, point C,
Can you tell me with clarity which are the points where we have the point forces?
Point D and point Charlie.
C.
Why RA is not a point force? RB is not a point force? Are they acting over a certain area, certain length?
That, sir, we have already taken A and
No,
B.
you have taken is fine. I want to know whether you understand the meaning of point forces. Tomorrow you'll say, no, we didn't take there. We took them as endpoints.
Yes, sir. So A, D, C, and B. All 4 points are
So
having.
guys, as per the first criteria, endpoints A and B qualify. Let's deal with the points separately. As per the point forces, A, D, C, B all qualify. Am I right, guys?
Yes, sir.
Yes, sir. Right.
Right? You have two common between the two. That's fine. That's a different issue. Tomorrow you should not say told us that point forces are only downwards. I have not said so here. Right? Am I clear, class?
Copy.
Here, I mean the point forces are the forces which are acting at a singular point. That's all. Whether they are acting downwards or upwards is immaterial, right? Clear, class? Now, next point will be fourth. Make SF table. And from the SF table, make SF diagram. Okay. Now, guys, I'll make the table with you. Now, since we have 4 points for which we have to make a table, see, I'll make the table here. I'll make 5 columns here instead of 4. Why? Because I'll also have to put the shearing force there with units. 1, 2, 3, and 4. Okay. Guys, this is shearing force, and what will be the units? Newtons. Guys, to make it convenient for sign convention handling, which direction did we agree to go from? Left to right or right to left? A
Left
while
to
back,
right.
left to right. Now, whatever you have named the points on the diagram, in the table, let them come from left to right in the correct order. Don't mess around with the order. So if I look at the diagram, how should my points be figuring in the table, guys? How should my points be figuring from left to right?
A, D, C, B.
A, D, C, B.
A, D, C, B. Now, guys, we will have to divide some. Sorry, A, D, C, B. Okay, B. Last is B. Okay, thanks. Now, guys, some of these cells, what do I mean by the cells? cells are these. These are the cells. Some of these cells for these points we'll have to divide into two. Now, what is the criteria for dividing the cell into two? All the points where you have point forces, please repeat to yourself, all the points where you have point forces will divide those cells into two. I repeat, all the points where we have point forces will divide the cells into two. Now tell me, amongst A, D, C, B, which all points have the point forces?
Sir, A, D, C, B.
All have the point forces. Does everybody agree? Yes or no?
Yes, sir.
Okay.
Yes,
So
sir.
we'll have, in this case, because all of them have point forces, that is why we are dividing all of them. Now, what is the purpose of dividing that? In the previous slide, if you see better, we had point 1 just to the left of A. In this, you see, where is the sudden change in the shearing force? Sudden change in the shearing force is taking at the place at the points where the point forces exist. Okay, and at those points, what did we do? We took point 1 and 2, we took point 4 and 5, we took point 8 and 9, we took point 13 and 14. That means a point just to the left of point and a point just to the right. So instead of making it so cumbersome like this, when we have divided into two, what does it mean? You don't have to write, I'm just doing it once. This space will treat as just to the left of A. This space will refer to just right of A, and combined it will show us what is the change at A. Likewise, this will be the shearing force to the left of D, just to the left of D. I'm using the word just. This will be just to the right of D. This will be just to left of C. This will be just to the right of C. This will be just to the left of D. And this will be just to the right of the D. No, last point is B, not D, sorry. Guys, have you understood why these cells have been divided? So that we can address the sudden change because of the point force existence. Is that clear? Clear, class? Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, guys, now I'm just going out of the PowerPoint presentation because I can't show that in the PowerPoint. Now, oh, did I delete it? Oh, chalo, koi nahi. No mind. I didn't keep it. I should have kept it now. I'll quickly do it. Okay, guys. Okay, points. Did anybody take the screenshot of the points I had written? Has anybody taken down those points?
Yes, sir. I have taken Durgesh.
Yes, sir, I write it.
You have written or you've taken the screenshot?
No, sir, I write it in my notebook.
Okay, just share that in the
Written,
group
sir.
if somebody has not done it. Okay. Anyway, sorry. Because I'll continue from where I left. Otherwise, we'll unnecessarily be wasting time. 30 newtons. We called it as D. C. RA was 49. RB was 31 newtons. And now we were on to making the SF table. One, two, three, four. Okay. Shearing force, its units A, D, C, B, and then we had discussed to divide them into two. And then I told you we'll fill up them in this order. Why? Because if you move from left to right, you don't have to number them like this. I'm just, for the first time we are doing it. Okay. And now what I wanted you to basically understand, let me now keep it and not delete this time. Is it all Everything I have deleted. This is too much. Okay, guys. Now I'll not be able to use the screen here, because if I show you something that I want to do, shape. Okay. Okay. I'm giving you a tip for 1 or 2 times, and then you don't need the tip after that. Okay. Then you'll not need this. Let me just outline also remove. Okay. Okay, guys. Now you see. Now when you have to understand. गायब हो गया. Let me explain this. Okay, guys. Now see. Let me remove the outline also. Now, guys, when you want the shearing force just to the left of A, just to the left of A, that means just you can tear a page of your notebook and cover just to the left of A. And now see, do you see any force to the left of A? Yes or no?
No, sir.
Okay. But एक मिनट इसको, why is it not getting hidden? This I have to fill up. Okay, 1 second. Second outline, text, shape, fill up. Okay, shape. Yeah, 1 second. Shape, white. Okay, now.
Okay, August 2024.
Beta, mute yourself, please. Mute yourself.
Beta,
mute yourself. Guys, mute yourself, please. Are mute yourself. Don't disturb the full class, please. Okay, now see. Now I have covered just to the left of A. Do you see any force to the left of A, guys? Yes or no? Tell me.
No, sir. No,
You
sir.
don't see. So that means in the first column, what will come? 0. That means this will be, there is no force just to the left of A, so shearing force here is 0. Understood, beta? Clear? Because we are going from left to right. Correct, guys? Clear?
Correct, sir.
Now,
Yes, sir.
move your paper and just take it to the just to the right of A. Just to the right of A, you have brought it here. Just to the right of A. Is there any force that has now changed from left to right? Yes. You can see plus 49 coming
Plus
into
49.
picture. So what will I do? I'll carry this 0 forward. That means up to left of A, it is 0. Now I'm allowing the change from just left to just right. The change is plus 49. That means shearing force at just to the right of A is 49. That means the change at A is from 0 to plus 49. Is that clear to everybody, class? Yes or no?
Yes, sir.
Yes, sir.
Now, I carry this plus 49 here. Now I'll see what is the change as I uncover from change only. I'm not saying total, I'm saying change, because up to just right of A plus 49 is already accounted for. Now I just go to left of D, just to the left of D. Now you see, guys, take your paper like this and go to just to the left of D. Is there any new force coming? 1 second, let me just cover that
Nice,
arrow
sir.
completely. Is there any new force?
No, sir.
So the change is 0. It will remain plus 49. I bring this plus 49 down here, and then I move my paper just to the right of D. What happens? Minus 30 comes into picture.
Yes, sir.
Correct, class? So minus 30 becomes plus 19. I carry this plus 19 here. And now I move it to just to the left of C. Is 1 second. Is the 1 second? Okay.
No other forces are related.
Okay. Is there any change?
No, sir.
Let me just take it. Let me hide the arrow completely for the benefit of those who may have confusion. Is there any change, guys, from right of D to this place? No, change is 0. If you don't want to write plus 0, it's okay. Once you become more proficient, you will be cutting short. Then plus 19, and I go just to the right of C. When I go to just right of C, you have minus 50 coming into picture. Am I right, guys?
Yes, sir.
Making it minus 31. I bring minus 31 here, and now I go to just left of B. There is no change. Remains minus 31. I bring minus 31, and the moment I go to the just right of B, plus 31 comes into picture. And when plus 31 comes into picture, it becomes 0. And this is how we complete the table. I am clearing this thing which I used, and now I'm going into screen share mode. Is the filling up of the table clear to everybody, guys? Tell me.
Yes, sir.
If you have a problem, initially you can use a scale, uncover gradually. And if you do it once or twice, then automatically the things will be falling in place. You'll not have to keep doing it. Is that clear, class?
Yes, sir.
Yes,
Guys,
sir.
now in our SF diagram, now last step you had written was the SF diagram. In the SF diagram, we'll have the same thing as earlier. We'll have point A, 10 meters from here we'll have B, midway we'll have C, and at 2 meters we'll have D. Our values in the table are ranging from plus 49 to minus 31. So you'll obviously graduate your thing. If this is plus 50, then 10, 20, 30, 40, 50, minus 10, 20, 30, 40. This will be SF in newtons, like this. Now, guys, you can see the cells which I have numbered. You will join these points. You will join these points. So at A, it goes from 0 to plus 49. It goes to 0 to plus 49. Then it remains plus 49 up to D, you see, from here. So I join this point, this point, this point, this point, this point, and this point. So it remains plus 49. I come to plus 19, remains plus 19, becomes minus 31, remains minus 31, and becomes 0. We get the same shearing force diagram through 4 points that we had got through 14 points. Correct, beta? Am I right?
Yes, sir.
So instead of wasting time and doing in a crude way of choosing 14, 16, 20 points, we'll use a systematic method of using the bare minimum. I'm not saying 4 will be always the answer. I'm not saying 2 will be the answer. I'm not saying 20 will be the answer. But whatever minimum is must. Anything less than the minimum can has the potential of making your diagram wrong. Anything more than minimum is not going to harm your diagram if you're correctly handling it. Only thing is it will consume more time. Okay, but minimum is must. Anything less than minimum is dangerous. Guys, have you understood what I have tried explaining through this? Because in the questions that we follow, now we'll start cutting short, and today we'll just focus on SF diagram. Please let me know if you have any questions to ask. Okay, good. Somebody had this. Oh, this is the other one. I was talking about the points where you had written 1, 2, 3, 4, guys. That do this, do this, do this, do this. Make the sharing beam diagram, calculate reactions, identify points. Anyway, that I can write again in the next question. Or you can write, I'll keep talking. Have you understood this simple sharing force diagram, guys? Yes or no?
Yes, sir.
Okay. Now, I'll test you at every point, and any point you make mistakes, we'll discuss that and you correct that. Now, can you now go to this one and make the beam diagram of this question, please, as per the language of the question. You have to make your own so that if you're wrong, you know why you're wrong and then you correct it. Okay, anybody in the class who doesn't know, has not understood the question and is struggling to make the diagram, because we have to address the point of difficulty. You cannot say, I don't know SF diagram, guys. You'll have to tell me which step is of concern to you. So we don't waste time on doing all the steps. We emphasize the point where you're getting stuck. Everybody has made a diagram?
Yes, sir.
Okay. Samir, have you made the diagram, beta?
सर बना रहा हूँ.
बना के बताओ फटाफट. हाथ से बना लो. You don't have to use scale. Scale you can practice later on. But if you want to use scale, use it. No problem. I don't want to discourage you. But anybody else who's struggling? Ali, have you made the diagram?
Yes, sir, already.
Okay. Because once I make and you compare, then you'll know if you're right, it's good. If you're wrong, then you need to. For this, everything we started discussing with in the morning, all that will have to be put to use. Yes, Samir, how far have you reached? Samir, diagram bana?
Yes, sir, बना दिया.
Okay, okay. Guys, now I'm going to make and I'm going to keep quiet and I'll only explain if people have a doubt. We have already discussed what will be represented how in all this that we have done. Guys, is this the diagram you made? Yes or no?
Yes, sir.
Yes, sir.
Anybody who wants to discuss the mistake he's made and wants to seek clarification? Samir, was it right? Was the diagram correct?
Yes, sir, correct.
Okay. Now, class. Next is getting the reactions. Let's say reaction here is RA, reaction here is RB. Can you please calculate the reactions? I'm writing the answers directly because I know by looking at the diagram, but if you don't,
25.
yeah, it is 25. Please calculate by moments if you have a problem. And I want you to apply common sense, guys. But if you are having a problem, we'll do it by moments also, no problem. Okay. Anybody who's not got the reactions 25 and wants to own it and discuss? Class?
सर एक बार मोमेंट से करके बता दिया। आई अंडरस्टैंड कि 50 न्यूटन का वेट है, 2 पॉइंट है इक्वली डिवाइडेड बाय 25।
वाई इक्वली डिवाइडेड,
बट
पिछले में तो मैंने 40-40 नहीं किया था, बट दैट इज अ फ्लॉड लॉजिक
या
यूर।
अच्छा, उसमें नहीं किया था बिकॉज उसमें देयर वर मोर पॉइंट फोर्सेस एक्टिंग in between
So
the 2 points.
so what difference? What is the correct reason? What is the correct reason?
And this is a uniform section beam.
So you
So the
no,
weight
you're
is equally divided.
it is there because about the midpoint of the beam, the upward and downward forces are mirror image on each side, right? Correct.
Okay, sir. Okay.
There, if you go to the midpoint and have a mirror there, the two sides are not mirror image in the previous question. That is the correct answer, right? Okay.
Yes, sir. Okay, sir.
Okay. Now, if you can qualitatively figure out, fantastic. Otherwise, we'll calculate. Guys, tell me, in the ship, is the weight of the ship all acting at one point? Is the weight of the ship acting at one point only? Yes or no?
No.
No. Why? Because ship comprises of a number of weights. It's light displacement, equipment, cargo, this weight, that weight, and they are differently distributed. Does each weight have the kg at the same point? No. Each weight has its own kg. The light ship will have its own kg. Cargo in number 1 hold will have its own kg. Cargo in number 2 hold will have its own kg. Derricks will have their own kg. Agdamba has so many things. But if I treat the ship as one body, then the entire weight of the ship can be assumed to be acting through fill in the blank. Center of the ship, is it? I repeat my statement. If I treat the ship as one as one body, then the entire ship can be assumed to be acting through
Center of gravity.
class.
Center.
Center of gravity, not center. What do you mean by center here? Center can be geometric center also. Center of gravity. So now here, is the weight of my beam concentrated at one point? Say yes or no only.
No.
Okay. But for the purpose of moments like ship, if I want to take this beam as one body for the purpose of moments, can I assume the weight of the beam to be acting through its center of gravity? Yes or no? Am I right?
Yes.
Like the ship. Because
Yes,
for
sir.
kg, you take moments about keel, na? And you treat the full weight of the ship. You say WF is WF multiplied by kg final. What are you doing? WF is not entirely concentrated at center of gravity. But you're saying WF multiplied by kg final. So you're taking the final moment. So for the purpose of moments, the weight of the beam can be assumed to be acting through its center of gravity. Please pay attention to my statement. For the purpose of moments, that means only for the purpose of moments. Otherwise, the weight is not concentrated at its center. So you see, I'm using a very light pencil. You can use a light pencil. I can assume 50 newtons to be acting through this point, which is half the length from point A. Yes or no, guys? Am I right? Correct? Now you'll say, sir, why are you not marking it dark? I'm not marking it dark because my weight is not concentrated here. It is being assumed to be concentrated here only for the purpose of moments. Okay. And if I may mark it dark, then it can confuse me when it comes to shearing force issue. So for the purpose of moments, the weight can be assumed to be acting through its center of gravity. Then how many total forces are in this question now then? There are three total forces. What are they? RA, weight of the beam, that is 50 newtons, and RB. Does everybody agree there are three forces? Yes or no? For purpose of moments. Am I right, guys?
Yes, sir.
So, taking moments about any one of support, so about point A, clockwise as positive and anti-clockwise as negative. There are three forces: RA, weight of the beam, and RB. Moment of RA about A will be RA into 0. 50 newtons can be assumed, the word is assumed, can be assumed to be acting through this yellow arrow. So the moment of 50 newtons will be clockwise. That means plus 50 into 5 minus RB into 10. Does everybody agree with me? The three moments, yes or no? Please tell me. Class?
Yes, sir.
Does everybody agree? And since the beam is not rotating, the resultant will be 0. Now, if you solve this, you will get RB equal to 25 newtons. And since RA plus RB is 50 newtons, therefore this implies RA will also be 25 newtons. Correct, class? Yes or no? Anybody who's not in agreement with me, tell me.
Correct, sir.
When these things keep repeating in the questions, please don't go back in for a spin. I'm not saying that 50 newtons is acting at the arrow, yellow arrow. No, it is being assumed only for the purpose of moments, right, guys? Now, look at the diagram and tell me. So, how many points, minimum points, we must take for the purpose of moments? Tell me. Based on the things we had done earlier. Some rules we had written. How many points minimum?
2.
At the end point.
Hmm.
तो ये
And?
दो हो गए.
Hmm.
Three,
And
sir.
We'll take
and
points where
and just before and
point
after.
forces set.
For the table,
Like
I said.
end points.
For the table.
End points.
Okay.
End
6.
points and just before and after end points. अभी के
अरे
लिए. In this case.
टेबल के लिए give me the number of points ना, before and after का क्या मतलब होता है टेबल?
6. Only
2
end
points,
points.
sir.
For table, either you'll tell me 2 or you'll tell me 4 or you'll tell me 3. For table,
Two, sir.
how many
2,
points
sir.
must I take?
3, sir.
3, sir.
Minimum
Okay.
2.
Okay.
5 points, sir.
Those
5
who are
points.
saying minimum 2, they are right. But if somebody says 3, as I said, if you take one extra, there is no harm done. Okay. Okay. Now, minimum were only 2 because end points and point forces. Point forces are only at the ends. Yes or no? Correct, Peter?
Correct, sir.
Yes.
Nevertheless, what I'll do is I'll make the table for 3 points. I'll draw the diagram with 2 points, end points. And we'll see what we get in the table and what we get from the diagram will be same. So I'm taking a point. This is not actually required. I'm sure those who said 3 points, they meant the center point. Yes or no? Am I right, guys?
Yes, sir. Correct.
Those who said 2 points, I'm again saying they were right. They were absolutely right on minimum number of points. So you were not wrong. Let me make that SF table. And please participate. Don't remain silent, because more you speak, more you will either find yourself correct, or you will basically find yourself missing out on some understanding and maybe seeking clarification. Guys, what should be the order of the points in my table? What should be the order?
ACB.
ACB.
ACB. Guys, is there a need to divide any of the cells into two? Tell me.
Yes,
Sir, A and
Yes, sir. A and B.
A and B.
Okay,
and B.
there is a popular opinion that A and B need to be divided. This is correct. If somebody thought they are not to be divided, or somebody feels C should be divided, please let me know. Don't keep copying. If you thought C should have also been divided, let me know. If you thought A or B were not to be divided, let me know. Then we can discuss that. Okay. Now, guys, please take a scale or tear a page.
नहीं सर.
हाँ.
सर
क्या?
C को क्यों नहीं डिवाइड किया सर?
So you were waiting for me to start further, beta?
नहीं.
The moment I started off, you thought let somebody else ask, why should I ask? Correct?
नहीं सर, आई वाज वेटिंग टू अंडरस्टैंड कि आपने C को क्यों नहीं डिवाइड किया. जब नहीं समझ में आया.
Okay. What was the? So then you should have said, no, sir, give me time.
Sorry sir.
What is the criteria for dividing? What was the criteria spelled out for dividing a cell? Tell me.
All points where point forces are acting.
So which point force is acting at C? Tell me, please.
सर बट हम assume तो कर ही रहे हैं ना, अगर C point ले रहे हैं तो.
So is the assumption same as reality?
नहीं.
So which point force is acting at C?
फिर तो कोई नहीं है.
So if it was acting, then why should we assume? Either it is acting or you are assuming, right?
Right. ठीक है, understood.
If it was actually acting,
हाँ, तब
then there was
लेते.
no need to say assumed, right?
Right sir, right, understood.
And I said we were assuming it only for the purpose of moments, right? Knowing fully well that the force is not actually concentrated at C. Yes or no?
Yes sir, yes.
Got your answer? The word assumption which you are using itself validates that there is no point force there. It was an assumption, right? For a certain purpose.
Right. Understood, sir. Understood. Thank you.
Now, guys, you can use uncovering imaginarily, or you can use a piece of paper physically. What will be the shearing force just to left of A?
Zero.
Zero. Everybody agrees in the class? Okay. I put 0 here. I carry forward this 0 because up to that point 0 accounts for everything. As I go just to the right of A, what is the change? Only the change. What is the change as I go to just
Plus
right
25.
of A?
25.
There is one.
25.
Don't say only 25.
Plus
Please
25.
use the sign. Yeah. Don't say that absence of sign is plus. No. Plus 25. Everybody agrees?
Yes,
And
sir.
now I'm already
sir.
warning you to be little careful so that not many of you make that mistake. Now, plus 25, I carry forward from here. Uncover from right of A to C. And see if any force is getting uncovered. That is the change. I have always given you.
Minus 25.
Okay, there are two people who are saying minus 25. Anybody else in the class who feels minus 25? Then I'll ask you, what is this minus 25? Is there anything getting uncovered as you move the page from just right of A to C?
Yes, sir.
Akshay?
हाँ जी सर.
हाँ, change from right of A to C. Uncover करोगे तो क्या कुछ फोर्स आ रही है एग्जिस्टेंस में? नहीं.
नहीं कोई नहीं आ रही.
कोई नहीं आ रही. What about the weight of beam of 5 meters?
So,
which is getting
equilibrium beam है, yes, -25 आएगी.
equilibrium
beam है.
नहीं, no equilibrium नहीं है, uniformly distributed beam है.
यूनिफॉर्म डिस्ट्रीब्यूटेड वेट है, तो 5 का वो 5 into 5 25 आएगी.
और वो डाउनवर्ड एक्ट करेगा, अपवर्ड एक्ट करेगा?
अच्छा डाउनवर्ड.
तो प्लस होगा माइनस? तो पूरा बोलो ना भाई.
-20.
So the weight of the beam is -5 into 5. 5 meters, 5 newtons per meter, making it 0 at C. Correct, class? Yes or no?
Yes.
Anybody in the class who's not understood shearing force at C? Okay. Guys, we carry forward this 0 here. Uncover from C to just left of B. Is there any change?
Yes sir, -25 again.
-25 again, because another 5 meters is getting uncovered. So just to left of B, it becomes -25. We carry -25, and then you have +25 coming into picture, making it 0. Is completing of the SF table clear here? Please let me know if anybody has any questions. Anybody in the class has any questions on this? See, I'm giving the full session to SF, because SF, if you make wrong, your entire question is going to be wrong, and it starts with the correct diagram of the beam. Guys, can I move to SF diagram then, if everybody is okay with the table?
Yes, sir.
Yes sir.
Now the SF diagram. I'll make the diagram using A and B. As I told you, C was an extra point taken. And why did I prefer to take C? I wanted to see whether you apply, you divide C into 2 or not. That is one thing I wanted to test. Second, I wanted to see whether you apply the weight of the beam in phases or not. Therefore, though 2 points were required, I was also keen to take 3, just to make sure that certain issues get sorted out. Now, guys, my SF requirement is +25 and -25 maximum. When it is such a case, same values on both sides, don't waste your time. You can just, what you can do is like this. Whatever distance you take here is +25, same distance on the other side, you can take -25. You need 2 points A and B. And you only use A and B values to draw. Guys, let me change to red marker. I have to join this A to +25. Then +25, I have to join to -25 here at B. So I'm not using this ignore this. Okay. It is -25 here. And I will show you that from graph also we get 0 at C. And at B it becomes 0. Okay. Now guys, I go from 0 to +25. Guys, look at the diagram. Which component, pay attention to my statement, which component is responsible for changing the shearing force from +25 to -25? Which component? Name the component. Is it the reaction? Is it the reaction? What is responsible for changing from +25 to -25? I'm only prompting you by naming reaction. Which
Weight of the beam.
Weight of the beam? Yes or no? Guys, why did it change from +25 to -25? It changed because of the changing weight of the beam. As you went from left to right, more and more beam was getting uncovered. Yes or no?
Yes sir.
Guys, the change from plus 25 to minus 25 was propelled by what? By weight of the beam. Yes or no?
Yes, sir.
Class?
Yes, sir. हाँ सर ठीक है.
नहीं नहीं, तेरा तो ठीक है बेटा, औरों का nobody else seems to be in agreement. Guys, is
Yes,
the
sir. Correct.
yeah, right. Now, when the rate of change is uniform, the weight of the beam is changing uniformly at what rate? 5 newtons per meter. If the rate of the change of the beam is uniform, then from physics we know that if anything has a uniform rate of change, its graph is always a straight line. I'm saying straight line, I'm not saying vertical, horizontal, slanting, whatever. Saying only a straight line. So since the cause of change from plus 25 to minus 25 is at a uniform rate, therefore the graph from plus 25 to minus 25 will be a straight line. I've given you the reason. I didn't say just join them with a straight line. No. So you now take your scale, put at plus 25, put at minus 25 and join it with a straight line. And then from minus 25, it becomes 0. This red one is the SF diagram. Understood, guys? Comprising of two triangles. And guys, this side is plus 25, this side is minus 25. Where is it going to cross the x-axis? At the mid length? Yes or no? Am I right? Correct?
Yes, sir.
Yes, sir.
So from the diagram, what shearing force are you getting at C, as at C? 0.
0.
What was the shearing
0,
force
sir.
in the what was the shearing force in the
0.
table at C? 0. So basically you needed only 2 points, but if you took the third one and applied correctly, you see sometimes what happens is if I take an extra point, that means my mind is probably working on a slightly off track, slight off track, and chances that you take an extra point and then do correctly will be little lesser, because the fact that you are taking one extra point means you're thinking something else. So though technically I say if you take extra point there is no harm, but taking extra point and remaining on the right track is also important, guys. Then had I plotted this with 3 points, I would have plotted at C0 and then automatically these 3 points will fall in a straight line. That's not an issue. The rate of change is a straight line. Why is it a straight line? Because the change was propelled by weight of the beam. Weight of the beam is changing uniformly at a rate of 5 newtons per meter. Therefore, this will be a straight line change. And we get these two identical triangles, one above the x-axis, other below the x-axis. And this red one is the SF diagram for this case. Is it clear, class?
Yes, sir.
We'll do one more question and then I'll tell you to practice at home. I know we are nearing the end of the class, but never mind. Because tomorrow we'll graduate to BM then, and then tomorrow we'll solve questions on beam. Guys, can you please make the diagram for this beam? Make the diagram for this beam whatever you think appropriate. Once you make it, let me know. I'll make it, and I'll make it silently without explaining. So, and I'll explain the discrepancies if you raise any. Hi guys, bana diagram?
Yes, sir.
Okay. Now I'll quietly make it, and even if there's a mistake, you should be able to understand and figure out where the mistake is. I'll use distinct colors so that there is no ambiguity. You can use pen and pencil combination in your exams also. Anubhav, mute kar lo beta. Anubhav, mute. Thank you. Guys, is this the diagram you have made or anybody has messed it up?
Yes, sir.
Excuse me,
Same,
sir. If
Yeah,
in
tell
the
me.
center, instead of showing the force from top, like how you have shown 10 Newton, is it okay to notate like down?
So you want to hang it like this with arrow downwards?
So same. I mean, is that also okay? Same.
It's okay. It's acting downwards. Doesn't make a difference. But why you want to show it like this? Any particular gain you are getting out of it?
No, sir. It's just I made it like that. I wanted to know
No,
whether
it's
that's
okay.
wrong.
It's okay. As long as the arrow is downwards, not upwards. Have you put the arrow upwards or downwards? Or you have not
But
put the arrow? Samuel, have you put the arrow or not?
I put it downward, sir.
Okay, then it's okay. Okay, guys. Now, there will be reaction. What will be the total reaction, guys? How much will be the total reaction? Tell me. What will be total reaction, class?
90.
90 newtons. 90 newtons, okay. And you will have reaction at A. And you will have reaction over this 4 meters, guys, which will be uniformly distributed. Like the weight of the beam in the previous case, for the purpose of moments, what did we do? We assumed it to be acting through its center of gravity. The reaction is like buoyancy. The buoyancy of a ship is contributed by underwater volume from forward end to aft end, from port to starboard, from keel to waterline, and different portions offer different buoyancy. But when you treat the full buoyancy as one, then you assume it to be acting through its center of buoyancy assumption. Akshay, is that clear? That's an assumption, right? Correct? So, guys, for the purpose of moments, now I'm just using a yellow marker again for the purpose of demonstrating you and not highlighting the thing here. There are 3 uniformly distributed forces, maybe upward or downwards. One is 30 newtons. I'm sure you'll agree for the purpose of moments, this 30 newtons can be assumed to be acting through here. Yes or no, beta? It's center of gravity, correct?
Correct, sir.
Where can the weight of the beam be assumed to be acting through? Weight of the beam can be assumed to be acting through here.
Center.
Yes or no?
Yes, sir.
And where could be the reaction over 4 meters be assumed to be acting through? That could be assumed to be acting upwards from here. These three arrows are the centers of these three uniform forces. Am I right, guys?
Yes, sir.
Does everybody understand? Yes or no?
Yes, sir.
Does it mean the reaction on the right side acts at one point? No, it's distributed over 4 points. Let me just call this as X, this point as X. Now, can we now get the reaction at A and reaction at X? And then, of course, reaction at X is not concentrated. It is distributed over a 4-meter span. So now, guys, can I write like this? Tell me. Taking moments about point A clockwise as positive, you can write full, anti-clockwise as negative. Guys, I still at this stage, what do? I go to rough and I write down the forces that are in the diagram from left to right. Can you identify the forces for me, guys, from left to right? How many are total forces? Can somebody count 1, 2, 3, 4, 5, 6? How many are the two? 5.
5.
5. Very good. One is RA, then other is 30 newtons, other is 50 newtons, the weight of the beam, another is 10 newtons at mid length, and last is the reaction at X. These are the 5 forces, and I'll have to take moments of these 5 forces. I still list them so that I don't miss out any force. Now, RA lever about A is 0. 30 newtons, the lever will be 1.5 meters. Am I right, guys? Yes or no?
Correct, sir.
Okay. So it'll be clockwise. So plus 30 into 1.5. Then 10 newtons, the lever is 5 meters. Again clockwise, 10 into 5. So is the uniform weight of the beam, 50 into 5. And then we have the reaction causing anti-clockwise moment, Rx into 10 minus 2, 8, becoming 0. Does everybody agree with this expression that I have written? If anybody has not agreed or not understood, please let me know.
Agreed, sir.
Any guys, tomorrow you should not be struggling for reaction and stuff. Please see if anybody has any question. If you don't have any questions, then can you please calculate Rx and give me Rx is how
Sir,
many?
सर RX into 8 कैसे आ गया? 8.
What as per you, what should it be? You tell me what should it be as per you?
सर 4 meter divided by 2 किया सर.
As per you, what should be the lever for Rx is my question. मैं नहीं पूछ रहा 4 divided by 2 किया था. 4 by 2 किया था. What is Rx into what should be the lever as per you? Why is the lever of 10? Why 10 is multiplied by 5? Can you tell me?
इक्विडिस्टेंस किया है सर. इक्विडिस्टेंस है इसलिए.
Sameer?
यूनिफॉर्म क्रॉस सेक्शन है सर, इसलिए डिवाइड बाय 10.
अरे why
5
10 is a point force? Why 10 was multiplied by 5 is my question.
10 multiplied by 5 बिकॉज 5 तक लेंथ है, उधर तक 5 मीटर तक लेंथ है.
कहाँ तक? कहाँ से?
बीच में तक इक्विडिस्टेंस है 10 मीटर तक.
इक्विडिस्टेंट 10 मीटर तक मैं समझा नहीं. And why is this 30 multiplied by 1.5?
सर बिकॉज 30 का 3 मीटर तक है. 30 नॉट 30 न्यूटन, तो डिवाइड बाय 2 किया सर. 4.5.
तो कहाँ से 1.5 ये 1.5 कहाँ?
ए से सर.
ए से ठीक है.
ए पॉइंट से सर.
ये 5 कहाँ से है?
ए पॉइंट से सर.
तो x a से कितना दूर होगा?
एक्स ऐसे 5 सर. 8 होगा सर 8.
So what is the doubt? When you are putting it for 30 and you're putting for 10 and you're putting for 50, then why you're having doubt about X?
समझ गया सर, समझ गया, अंडरस्टूड.
If you have doubt in the previous ones, then only you'll have doubt in X, na beta. You can't have everything in place and suddenly X is bothering you, correct? Arey, what is this distance, bhai?
Yes sir, understood sir.
Guys, how much is Rx coming?
43.125.
43.125 newtons. Now, I will write here, but that is of no sense. So Rx is 43.125, but it is not concentrated. Divide by 4. I'm writing here. When you divide by 4, it is 10 point, how much beta? 3 decimal place.
781.
781 newtons per meter. Correct, beta? It is not at the arrow concentrated. It was assumed to be acting through X. Yes or no, guys? It's actually acting over 4 meters in length. Right, guys? Samir, is that clear?
Yes sir, clear sir.
Okay, guys. Now, based on 2 rules that you had written earlier, can you tell me total how many points based on 2 rules for SF table? How many? Based on those 2 rules, how many minimum points for SF table?
5.
Bolo bhai. Based on those 2 rules, 5. Is that the answer?
So based on those 2 rules, only 3 points.
Only 3 points, correct? Yes or
Three,
no?
sir, 3 points.
Two end points, and there are only 2-point forces, Ra and 10 Newton. So 1, 2, and 3 based on those 3 rules. Yes or no? Am I right? Now
Yes,
look
yes.
at now we had left a third point to be discussed later. Now we are coming to that. Look at this diagram. When you start running on this diagram from left, is there any break of any uniform force? That means, is there is a point where any uniform force is terminating? So when I go from here, you tell me to stop where any of the uniform forces comes to an end. End or start.
Stop.
At the end of weight, sir,
Yeah.
30.
Stop.
Here, this uniform force is coming to an end, right, guys? So this point will have to be taken. Okay. And then, if you continue, a new uniform force is starting from here, correct? Wherever there is a change in the uniform forces, that was point C, which was left blank. That in case of uniform forces, wherever there is a change of the uniform force, those points will also to be included. Am I clear about the third rule? Yes or no, beta?
Yes,
Tell
sir.
me.
Yes, sir.
Okay. So somebody said 5. He was giving me the final answer, which is correct. Somebody said 5 points. It was correct. But he was not giving to the question. He was giving the final answer. So guys, in this, there are 5 points. Samir, is it clear why 5 points?
Yes sir, clear sir.
Now we'll name those points. You can name A, B, C, D, whichever way you want, guys. P, Q, R, S, no problem. Let me call it as C here. Let me call it as D here. Let me call it as E here. So now we'll make the SF table for 5 points. And please participate in making of the filling up of the SF table. One, two, three, four, 5. With respect to my diagram, SF will be newtons. Can you please give me the order in which to fill up the points as per my diagram?
A, D, C, E, B.
D, C. I'm randomly naming them so that this point about order is respected. Guys, is there a need to divide any of the cells? Is there a
Yes,
need
sir.
to
It's a
which
C.
ones?
Yes, sir.
Yes, sir.
A,
Which
Where
one?
point force is acting.
No, you have to
A,
give me the points.
A, C, and A, C, and B.
A and C, sir. A and C
B.
only.
A and C.
Which point force is at D, beta? Can you tell me which point force is acting at D? Which point force is acting at D, beta? Can you see any point force at D in the diagram? Somebody said D. I'm talking to him. No, he doesn't
No,
want to
sir. I
respond.
said B accidentally.
Okay.
It's sorry, it's my fault.
No,
A and
no,
C.
sure. A and C. Now, guys, if you are proficient, you can uncover without paper. If you still have doubt, use the paper. What will be the shearing force to left of A?
0.
0. I carry forward 0. Just 1 point to the right of A. What is the change? Okay, first tell me what will be RA. RA will be equal to, you said 90 minus, sorry, I forgot to write this. This will be equal to 725, 89, 6,
875.
46.725, correct? Have I written it correctly, beta? Am I right?
8.875.
875. 87. Okay, 875. Okay, it's 875. Okay, not 25. 875. Okay. So what is the change from just to left of A to right, just right of A, guys? With sign. With
Plus
sign.
46.875.
875. So it
Plus
becomes
46 decimal 86
875. Very good. I bring forward this 46.875. As I go from just right of A to D, be careful. What are the changes? Identify the changes, and I'm telling you, I can see two changes happening. Can you please identify them?
So 30 plus.
The uniform weight.
So you
Is,
tell me, tell me the value and sign.
minus 30.
Minus 30 newtons, the weight which you correctly identified,
Minus
and
50.
and minus
Minus
and
15.
minus the
50,
and tell yourself like this: minus the
50.
weight of 3 meters of beam, minus the weight of 3 meters of beam, right, guys?
Yeah,
Correct.
Yes, sir.
So minus 45, it
15.
leaves you with 6.875. Am I right, guys? Correct.
16.
1.875.
16 to me.
1.875.
1.875.
1.875.
Okay, it's 1.8.
1.875.
1.875. Okay, my mistake. 1.875. We carry forward this plus 1.875 here. If I make any mistakes, it will not be zero at B. Don't worry. The question will bring me back to my table again if I make a mistake. Guys, what is the change up to left of C? Because C is divided into two.
Minus 5 into 2.
Minus
Weight of the
5
beam.
into weight of the 2 meters of beam, right? So
Yes, sir.
minus 10. So this becomes 0.25, 0.2125. 0.125 and 9 8.125
Minus,
is
minus
Yes.
8.125.
minus 8.125. We carry forward minus 8.125 and then we have minus 10 the point force, making it minus 18.125. Correct, class?
Correct,
Yes,
sir.
sir.
We carry forward this minus 18.125 and then we have 1 meter weight of the beam from C to E. Correct, guys?
Correct, sir.
Minus 5.
So minus 23.125. We carry forward minus 23.125. What are the changes taking place from E to B, guys? One is the total reaction acting upwards, correct? That is
That will be minus 20 plus
Minus 2
and
into
43.125.
5.
minus 20 minus 4, 5 into 4, making it 0. Correct, guys? And the fact that it has become 0 at B, that means I don't seem to have made any mistakes. Is everybody okay with the table, guys? Let's have a look at the table. Never mind, another few minutes. Doesn't matter.
Yes, sir. Correct.
Now we make the SF diagram. Guys, I always spend this full session on SF diagram because if you're wrong here, you'll be wrong further also. So there is no scope for. We look at the scale plus 46, minus 10, minus 23. So I need lesser on the minus side. I need more on the plus side. So I can have a table like the scale like this depending on my space. If I have A here, I have B here somewhere. I have C in the mid length. Then 2 meters to this side, I have D. And 1 meter to this side, I have E. So this is 3 meters. This is 2 meters. This is 1 meter. This is 4 meters. 10, 20, 30, 40, 50. 10, 20, 30. This is SF. You put the units, calibrate both the axes. And now, guys, I'll just first put the points, and then in discussion with you, I'll join and we'll complete the SF diagram. We'll have 0, which will be joined with plus 46.875.
Somewhere else.
Then we'll go to plus 1.875. Then we'll go to minus 8.7125. Then we'll come to minus 18. Then we'll go to minus 23. Then we'll go to 0. Now, guys, your attention will be going between the diagram, beam diagram, and the SF diagram. So what am I saying? SF diagram, better mute yourself if you're not talking to me. Your SF diagram, what happened? What happened? What happened? Why is it going back? 1 second. What happened? 1 second. 1 second. Guys, what am I trying to say? Okay. What am I trying to say? That your SF diagram will draw its shape from the beam diagram. So you will be, wherever you have to join points, you'll have a look at the beam diagram. At A, it does not need any discussion, 0 to plus 46.9. From plus 46.9, it has to come to this point. Guys, look at the beam diagram. What are the factors changing the SF from A to D? One is the UDL and other is the weight of the beam. You can see two things coming here in the table also, 1 and 2. Yes or no? Am I right? Look at the diagram. There are two factors bringing the SF from 46 to 1, plus 46 to plus 1. What are they? UDL of 30 newtons and the weight of the beam. Correct, guys? Yes or no? Am I right?
Correct, sir.
Yes, sir.
And are both the factors at a uniform rate? Are both
Yes,
of them
sir,
at
at uniform rate.
So resultant will also be at a uniform rate.
Straight line.
So we'll put a scale and join them with a perfect straight line here. Then, guys, look at the diagram again from D to minus 8 at C. What is the rate cause of the change? Speak of the cause. Name the cause.
The
D to
uniformly
C.
distributed weight of the beam.
Beam weight, uniform, right? So
Yes, sir.
again, put the scale between these 2 points and join them with a straight line. Then minus 8 to minus 18 needs no discussion. Then, guys, from C to E, the change is because of the weight of the beam. Again, uniform. Then, guys, from E to B, the change is because of the weight of the beam, which is uniform, and the reaction, which is also uniformly distributed. So the change will again be uniform. And this is the SF diagram of this question. Is it clear to everybody? Clear class? I can put the values. This is minus 1 के बाद it is minus 8.125. Then it is minus 18.125. And it is minus 23.125, and that is 0. Is it clear now, guys? Is the SF diagram clear for this question? Anybody has any doubts?
Yes, sir, clear.
Please have a good look at what we have discussed today. Have a good look at these SF diagrams with reasoning and logic. And if you have not understood anything, let me exactly know which question, what was the trouble area. Okay. And but please have that sorted out at the start of the class. If we start at 9:35, then if you are there with the doubts, I'll take the doubt. Otherwise, we'll move on with PM. Is that clear for tomorrow, guys?
Okay, sir.
And tomorrow tomorrow we'll finish with SFBM of beams. Tomorrow we'll be through with SFBM of the beams. I have nothing else for the day. I'll just share with you the prior learning questions. And if it's okay with you, then we can sign out, guys. Any questions? Okay, then see you tomorrow, guys, at 9:30.
Okay, sir. Thank you.
Bye. Bye.